All right, how's it going, guys? So I have the Harris-Benedict equation here that I'm going to be discussing. So I have a client that actually is non-obese. She weighs 147.5 and she is 5'4" and she's 42. So what we're going to do here is looking at our Harris-Benedict equation. An equation right here that's for the non-obese adults. That's the Harris one, and that's for the Benedict men. And here's the equation here, and the Benedict equation for women. So this is the actual resting energy expenditures in kilocalories per day. So what that is telling us is that this is only if they're just resting there through the whole day. And then it'll tell us how much energy they're actually using within that time frame, the 24-hour period. So here, what we have is 66.47 plus 13.75 multiplied by the weight, and that's in kilograms, and then plus 5 multiplied by the height, which is in centimeters, minus 6.8 multiplied by the age. So with that in mind, we have all the different equations here, and then the Mifflin equation for obese adults. And it's going to be a tad bit different, but it's very similar, and it's a little bit different for men and for women. So what I've gone ahead and done with this whole Excel spreadsheet is I've actually entered in some fields here. So as you can see, this legend over here, this is all just for information here. The equations and the calculations are all going to be performed within these cells over on the left side. Well, the legend over here, you can see the light green, which indicates up here. It indicates input cells, so basically that's where you can add in values. And the light orange indicates non-obese individuals, and the very light is for obese individuals. So oh yes, and then this very light blue is that's the activity factor that will be provided in the end. So for my client, she weighs 147 pounds, and the actual pounds and the units are located right next to the header. So for the weight over here, I'll convert it into kilograms, and then the height will be converted into centimeters from over here. The age, just the age. And as you'll see right here, at 47 pounds, the equation is actually going to, this right here will convert it from, it'll take this cell, the pounds, and then divide it by 2.2, and that converts it into kilograms. Next, we have the height, which is in feet, will need to be converted into inches, and then it'll have to be added to the remainder of inches that the individual is. And that's what this cell does. So as you can see right here, we have the height in feet multiplied by 12, and then added to it is the remainder height in inches, and they're added together, and then they're multiplied by 2.54, which converts it into centimeters, which we see here. But as we're doing in the example, the female that we're going to be looking at is 5 feet 4 inches, and so the height changes. Then she's 42 years old. So from this criteria, we can actually go ahead and determine for the resting energy expenditure, we are actually it's going to calculate for men. It's going to utilize for the non-obese area. We already know that it's a female, but I just wanted to go over these calculations just to show you what this does. So this is going to be the first section of the calculations right here. That's a male, sorry. And then a female is right here. And it'll take these calculations up here. And this is just taking the weight in kilograms. And right here, F11 is the height in centimeters. And then H8 is the age. And all that's doing is just taking these sections right here and just inputting them into a cell so you don't have to do the calculations later on. Much like the other, for an obese male, it would provide you with this obese adult equation for the resting energy expenditure in kilocalories per day. You'll see right here the weight, the height, and the year, the age in years. This is going to be represented by this equation. Females is going to be represented down here. And then what it does is that provides you with the resting energy expenditure. And since we know we're dealing with a female that's non-obese, we take this, her resting energy expenditure, and this is if she's not doing anything, she's just laying in bed for the whole day, is going to be 1,401.7 kilocalories per day. So now we want to incorporate their total energy expenditure that includes body activity, like moving your arms, watching TV, thinking, whatever, running. So to do that, they have provided an activity factor, which I have provided columns that will calculate all the different activity levels. So we have the sedentary, light activity, moderate activity, very active, exceedingly active, and what it does is it actually takes this value and multiplies it by these different cells. So even if this was a male at that height, at that age, we could convert it and use it right here. But we're looking at the female, so we'll say that she's very active. And so we can step over to underneath the very and then go to the female, and we know that it's light orange because she's non-obese, that her energy expenditure, total energy expenditure for the day in kilocalories per day, is going to be about 2,417.9. So this is what this Excel spreadsheet can do, and you can see right here, essentially what it does is it just takes this value for the woman and then multiplies it by 1.725. So I hope you guys enjoyed that. It's surprisingly it's pretty fun to put together, and a lot of what was discussed is essentially providing the individual or the client and saying, hey, this is where your energy expenditure is, and if you can, it's gauging for calorie intake. So if you stay underneath this amount for your calorie intake for the day, you're gonna have you're gonna expend more energy than you're consuming, and that should assist in losing weight, or whatever they're shooting for, or just maintaining if they want to do the same amount, essentially, or even bulking up also, because let's say an individual wants to gain mass, they're going to have to exceed this energy expenditure. So I like it because then it kind of shows, well, if you're really even if the female, let's say she's like, well, I really want to start going and working out, what's going to be my total energy expenditure for the day, and you got it right here already. Well, if you're exceedingly active, which is the highest level that we got here on this equation for the Harris-Benedict equation, you're going to be expending 2,663.2 kilocalories per day. So that's, I mean, it's a quick and very nice reference. I like it. So I hope you guys enjoyed that. Thank you.